Okay, so up to this point, we have no official values for A, B, or C. And so we're going to utilize the Pythagorean identity along with the ratios we determined by isolating C to solve for A. So if we go to solve for C with these two, you're going to get B is equal to A sine of C. In order to isolate C, we're going to divide each side by A. And A, of course, on this side is going to cancel out. So sine of C is going to be equivalent to little b over A. And similarly, with cosine, we're going to get little a is equal to A cosine C. Same step, divide by A, cancels out. C isolated is going to be equal to little a over big A. Now, using these two ratios that we found, we're going to plug it into the Pythagorean identity to help us solve for A. So we're going to get we determine that cosine is equal to little a over big A, that quantity squared, plus sine of C we determined was little b over big A squared is going to be equal to 1. And when we multiply this out, a squared over big A squared plus b squared over big A squared is going to be equal to 1 squared. 1 squared, of course, is going to still be equal to 1, but common denominator, we're just going to simplify it out. A squared plus b squared over big A squared is equal to 1. So we're going to isolate big A, so we're going to take it into a squared is equal to little a squared plus b squared. Square root it out. Big A is ultimately going to be the square root of a squared plus b squared. Okay, so now that we found that sine of C and cosine C can be represented as ratios, we're going to go ahead and just tie it into a simple right triangle with C being our theta. And we know cosine is, of course, adjacent over hypotenuse. Likewise, sine is going to be opposite over hypotenuse. And we know A has to be the hypotenuse because we just derived that A is going to be the square root of little a and little b squared.
Okay, to one of our final steps, we need to write our original equation that we graphed, sine x plus cosine x, in the form y equals a sine of bx plus c. So to do this, we're asked to find the values of little a, little b, and big B. Well, if it's going to be in the form, if this is going to be in the form of this, as you've noticed from these equations, that there is no little a or little b, or big B for that matter. So, and we'll find A and C later, but generally in mathematics, when an equation is not expressed, it has to be 1. And that's the general rule. So, because all of these are not expressed, they're going to be 1. 1, 1, and 1. So, we found big B, and that's going to have an impact on the graph. That's most likely why our first graph was inconsistent with, or our approximation graph was inconsistent with the first graph, is because our B was not 1. So, because we have these values, A and B, we can start to solve for big A with the Pythagorean identity, and when we have those ratios, we can solve for C. So now that we have little a and little b, we can solve for big A. So in our equation originally for big A is equal to the square root of a squared plus b squared, as you can see. So we just plug in our values that we have. Square root of 1 squared plus 1 squared, which will, 1 squared is 1. square root of 1 plus 1 is 2. And the square root of 2 is irrational, so we'll leave it in the radical form. So a equals rad 2. And now that we have big A, little b, and even big B, which will help us in the end, we can plug it into our ratios, which will help us find C. So we know that sine C equals little b over big A. Well, we know that little b equals 1 over A, which is rad 2. And our cosine C is exactly the same. Little a, which is 1, because we've already established that 1 is not represented in mathematical formulas generally, over the rad of 2. Now by using sine C and cosine C, we find lengths, but the problem is that we need to find the form, that we need to find C, which is an angle. In this case, to find C, we would be finding the reference angle. So we have our ratios, and we can just put them in. So B is equal to 1, all their equivalent forms, rad 2. So to find C, which is an angle, we find the arc sine of 1 over rad 2, which will equal our theta, our reference angle, which will ultimately equal C, and our cosine, arc 1 over rad 2, which will equal theta hat, which will be C as well. And we really don't need to do both of these. We really can just find sine, since both of these ratios are the same. It wouldn't even matter even if the ratios weren't the same. We'd still find the reference angle. But this is a recognizable form. It's one that we've went over and over and over again. And this would be 40, C would equal 45 degrees, or because we graphed it and it was a sine curve, has to be in radians, pi over 4. And actually, the sine and cosine are useful because when you put it on a unit circle and you find your ratios, cosine is represented as your x and sine is represented as your y. So if this is the point and our reference angle is pi over 4, then the 2 points that we have for x and y are 1 over rad 2, comma 1 over rad 2. And it makes sense. That's what we've learned. So now that we have these values, we have C, we have big B, we have big A, we have enough information to plug this in to this form and see if it is equivalent to this for all values of x. So finally, we'll go to the graphing calculator in a bit, but A equals rad 2 sine of bx, which would just be x because 1 is not represented in this case, but plus, by a numerical value anyway, plus pi over 4, because we are graphing it, needs to be in radians. So we'll go to the graphing calculator. And so here are the two equations. You can see we've mapped this one all out. So we'll press enter, and then we'll graph them. And this is what you get. But it's not showing that the rad 2, we're not sure, we can't know for sure if they're equivalent. So we go back to y equals, and we'll clear that graph. And we find that these graphs are essentially the same. In fact, we'll see if their approximations are the same. Calc, so we'll find the 0, lower bound, right bound. And they are the same, they have the same shift, and we can go a step further.
find the phase shift, or the period, sorry. Calc 0. Here's our left bound. Here's our right bound. And there we go, 5.49, which is the exact same value as the previous one. And now that we're out here, we might as well just find we can already tell that there is no vertical translation. So we'll find the maximum value. Just do it. Let's calc. Maximum 4. Left bound should suffice. Right bound. And there we go. Y is 1.4142. So these equations, as we can say with this form, sine x plus cosine x is equivalent to the rad of 2 times sine of x plus pi over 4 for all values of x.